Test rational functions inequalities. So here is a solution to your question number 1 on the test of rational function inequalities. It's a communication and thinking problem. Question 1 says, determine the solution set of 2x plus 1 greater than x plus 3 divided by x minus 1, the graph of the function given below. Now, this test has a couple of questions. I would like you to, whenever you see test on the top, I would like you to stop the video and copy the question. Once you do that, write down your solution. And once you have written your solution, then look into my answer, right? So I have not created two different videos in this series. What I mean to say, giving one question set and then the videos. I have incorporated answers in the same video. So before I give out my answer, it's good for you to answer yourself and then look into my suggestions, right? That will help you to understand the subject better. So I hope you have copied this question and answered it on your own. And now look into my solution, right? Here is how I will solve it. Question 1. Determine the solution set of 2x plus 1 greater than x plus 3 divided by x minus 1 and from the graph of the function given below. So normally we don't even give the equation, right? We just give a graph and tell you, well, these are the two graphs and let me name them. Let's say we'll call one of them as f of x. Let's say this is f of x and the other one, which is kind of a reciprocal transform function, as g of x. So these are our two graphs, right? In the given scenario, f of x happens to be a straight line. So we say, well, for us, f of x is equals to 2x plus 1, right? This straight line. And g of x is a rational function, which is x plus 3 over x minus 1, right? So these are the two graphs for us. So here you have a horizontal asymptote, which is the ratio. And let me just draw the horizontal asymptote for you here. It is not important for the solution of this particular question, but just in general. And a vertical asymptote is at x equals to 1, right? So let me draw a vertical asymptote also, so that you clearly see what the graph is, right? So that is how the real graph is. Now we need to determine a solution for the line. This 2x plus 1 is f of x, which is the line greater than the rational function. This is what the real question is. So we don't really have to do any calculations here. We have to just see from the graph and see where is the line above the graph. So as you can see from here, not including. So as you can see from here, this is the point of intersection and that is another point of intersection, correct? As you can observe from here, that the line is above this graph in this portion, right? So that is a part of our solution. In this portion, it is above, right? As you move out. That is a part of solution, right? Going up, correct? That is one part. Now, where else is this line above this graph, right? See, here it is below. Do you see the graph is above it, right? So it is below here. But as soon as you cross this vertical asymptote kind of thing, right? Here, then you see that the line is above the graph, right? At this point, it is equal to. So also in between here, it is above, right? So I'm purposely putting a bold orange here so that's visible and you can write down your answer, correct? So there is a discontinuity at 2. So we'll not talk about 2, right? So we say determine a solution set for this. Solution set is when is this statement true? That means when is f of x greater than g of x, right? So we see, well, the solution set is, well, these points of x values were interested. So this value of x, which is minus 1. And here, that value of x, which is 2. But not including these points. So we say, well, these points are that x belongs to real numbers, where x is greater than minus 1, but less than 2. That is one set. You can write union also, and union. The other set is that x is greater than 2, right? And the second is that x is greater than 2, right? So that becomes our set of solution set. Do you see that? So these are the two values. So on a number line, on a number line, if you have to draw this solution, you can say, well, that is my number line, here is my 0. So on a number line, my solution set will be from -1 to 2, this, correct, and thereafter, correct. So that is your solution set. This is from -1, this is 2, and thereafter, right? In coordinate form, you can also write in bracket form. So this is your solution, that is my solution, right? Or the answer for this question. You could say, I'm giving it different ways because many students are doing, some will be asked to do it in number lines, some in set form. So I'm giving you all different options here, okay? From -1 to 2, I should have -1 to 2 union 2 to infinity, right? 2 to infinity. You can never include infinity. That becomes your set, right? So these are different ways of answering this question. I hope you understand. It's a very important question for your test. So go through it, try to understand, right? At times there are situations where graphing is a better option than algebraic solution. You'll appreciate that also at times, okay? Thank you.